Hello everyone, welcome to another video. So today we'll be starting with the chapter continuity and differentiability. So the first topic is continuity. So what is continuity, right? So we'll be using continuity to find out if a function is continuous or not at different points. So if we take an example first, you'll understand it better. So we are having a question here, f of x, it is equal to 1 if x is less than or equal to 0, and it is equal to 2 if x is greater than 0. So we'll be graphing this equation first and let's check it out. So when x is less than or equal to 0, that means it has to be from this region till the point 0, right? Till this point it has to be x. So it is equal to 1. That means y is equal to 1 at every point when x is less than 0. So this will be the line which corresponds to the first part of the equation, f of x equal 1 if x is less than or equal to 0. And at the point x is equal to 0, that point also y will be equal to 1. Okay, f of x, it actually represents y, so it will be equal to 1 when x is 0. Then next we have to check at every point greater than 0. When x is greater than 0 means this region, right? So it is equal to 2. So it will be like this. F of x is equal to 2 when x is greater than 0. But in this case, x at 0, it is not included. So at 0 it should be only one point should be filled. It is 1 here, and there will be a hole at the point 2. When x is 0, there's a hole at 2 and it is filled in 1, and after the point 0 it will be full 2. So like this, if we check, when we are doing this, when we are drawing the graph, we cannot draw the graph continuously, right? We have to lift our arms and then only we can continue the drawing. We cannot draw it continuously because it's not a straight line, it gets divided in between. So this function is not continuous, at the point x is equal to 0, because at the point 0 we are lifting our arms and then drawing it, right? So only at this point the function is not continuous. Rest other points it is continuous. We no need to lift our arms in any other points. So first of all, to find if a function is continuous at a particular point, what we have to do means, first we have to find the limit of x tends to that point of the function, and we have to check there will be a right limit and left limit, and we have to check if it is equal. If both of them are equal, if the right limit is equal to the left one, then we have to find f of c, and we have to check if both these things, if they are available, we have to check if they are equal or not. And if all these three conditions satisfy, then only we can say that the given function is continuous at a particular point. And if we say a given function is continuous, totally means it is continuous at each and every point of its domain. So to understand this better, we'll take an example here. So we are having f of x, a function given. It is equal to 1 if f is not equal to if x is not equal to 0, and it is equal to 2 if x is equal to 0. So this is the graph of the function. If you see, so when x is not equal to 0, that means this point will be the point where x is 0, right? This point. So only at this point it is 0, and rest other points it will not be equal to 0. So it is equal to 1. F of x is equal to 1. So you can draw the line like this, and there is a hole at x is equal to 0 because we have another condition for x is equal to 0. In that case, f of x will be equal to 2. So at 0, at x is equal to 0, f of x will be equal to 2. Rest other points it will be equal to 1. So first of all, we have to check the continuity at the point 0, right? Because we are having different cases for 0 only, so we have to check at that point only for now. we'll be taking limit of x tends to 0 f of x, or in this case there will be two different cases, limit of x tends to 0 plus f of x and limit x tends to 0 minus f of x. So 0 plus means x will be little bit greater than 0. Like let's take an example like 0.1 or 0.01. It is close to 0 but not 0. So at this point the limit will be equal to 1 itself, because when it is not 0 it will be equal to 1, and when it is 0 minus means little bit less than 0, it will be like minus 0.01 minus 0.1 like that. So in that case also it is not equal to 0, so the limit will be 1. So both these are equal, so the first condition is satisfied. Now we have to find out f of c and check if it exists or not. So in this case our c is 0, right? Our point is 0. So f of 0 will be, what is f of 0? X is equal to 0, it will be 2. Now we have to check if both the limits and the f of 0 it is equal or not, right? These both are equal, but their answer it is not equal to the f of 0, right? Because we are getting 1 here and 2 here, so two different answers are possible, and that's why the function f of x is not continuous at x is equal to 0. Only at the point when x is equal to 0 it is not continuous, rest other points it is continuous. This is very simple to understand also, because while we are drawing, right, at 0 there's a hole, so we have to lift our hands and then after that we have to continue, right? So we are not drawing the line continuously, right? There's a gap, small gap in between, so that's why it is not continuous at the point x is equal to 0. So we are having a question here and we have to check if the function is continuous or not. So if you check here, we have to check at the point 0, right? Because we are having x less than 0 and x greater than or equal to 0. So at 0 the function is becoming different, so we have to check at the point 0, and other rest of the points it will be continuous only. So first of all we have to take limit x tends to 0 f of x. So in that case we'll be having two different cases, limit x tends to 0 plus f of x and limit x tends to 0 minus f of x. So first let's take 0 plus, means it should be greater than 0, so it will be x, right? The answer will be x. So then limit x tends to 0 minus means we have to take less than 0, it will be minus x, so it will be minus x. But in this case when x is less than 0, the x will be already having like minus symbol, so the minus will get cancelled and it will become plus x itself, because for example if you are having 0 here, little bit above 0 we can take 0.01 as an example, and little bit below 0 we can take minus 0.01 as an example. So in the first case if you are getting x, it will be like 0.01. In the second case it will be minus x, it will be minus x, right? So instead of x we have to put minus 0.01. So if you check the result, it will be actually equal to 0.01 itself, and you can say it's kind of approximately equal to 0 in both the cases, right? It's actually equal to, almost equal to 0. It's not 0 but close to 0, so the answer can be considered as 0. So this is our first step. Now second step, what we have to do means we have to find out f of 0. So what is f of 0? It will be equal to x. Now instead of x we are having 0, so it will be 0 itself. Now we have to check if the first condition it is equal to second one or not. So we are getting f of 0 to be 0 and limit x tends to 0, as both the case is 0 itself, all are same, so we can say the function f of x is continuous at all points. Next we have one more question here, and we have to show that the given function is not continuous at the point x is equal to 0. So for that, first what we have to do means we have to find the limit x tends to 0 f of x. So we have x tends to 0 plus limit of that, and limit of x tends to 0 minus. Two different cases. So above 0 means, or below 0, it's not equal to 0 means we can use the first equation itself, x cubed plus 3. So in the first case it will be x cubed plus 3 because it is not equal to 0. In the other case it is equal to 0, right? So when x is close to 0, instead of x cubed, we can put 0 itself because it will be close to 0 itself. So it will be 0 plus 3. So the answer will be 3. So now let's check limit of x tends to 0 minus. So in this case also we have to use the same equation. This is x equal to 0 and x not equal to 0. In this case also it's not equal to 0. So it will be x cubed plus 3 only. It will be close to 0 here also, x cubed. So we can consider instead of x cubed, we can put it as 0 and plus 3. So the answer will be 3. So first let's check if both the answers are same. The limit will be equal to 3 itself because both the answers are equal, and that's why the limit x tends to 0 f of x, it will be equal to 3 itself. Now we have to check the second condition. We have to find f of 0, and f of 0, it is equal to 1. It's given according to the equation. Now when we compare 1 and 2, the first one answer is 3 and the second one answer is 1, and as you can see both are not equal, and as both are not equal, the given function f of x, it is not continuous. It is not continuous at x equal 0 because we are having two different answers, and if both are equal then only it will be continuous. As both are not equal, at this point x equals 0, the given function is not continuous.